Okay, so force means pulling or pushing any object, right? So what is the meaning of turning? Shanad?
Turning is rotating an object.
Exactly. That means turning force are found in many everyday situations, right? And are essential
Yes.
for machine to function. Okay. Like where levers, gears make use of this turning force to provide an advantage. Okay.
Yes.
So a force may cause an object to turn about a pivot. You know the meaning of pivot? Straightforward.
Yes.
So if we have something like this, so this is an object, we are putting a box here, we are putting a box here, okay, and we are putting a pyramid here. So anything is going this way is a pivot, okay, P-I-V-O-T, okay. So another things can happen, that is clockwise or anti-clockwise. Okay, this is clockwise moment, like this. If I don't give any weight here, it will go downwards, right?
Yes.
If you put less weight here, what will go? It will go downward clockwise. It's circling like a clock pin. So and this will go like a anti-clockwise moment. Okay. So this is anti-clockwise. Okay. This is clockwise. This is reverse of the clockwise. So force is applying where? Here is one force is there, right? The weight is putting force. The another force is here. Okay. So another force is giving here. So this is pivot. It's pivoting this force of both sides. Okay. So if we consider this, the turning effect of a force is called a moment of force. Moment means in certain time of point of time, right? In certain point of time, if any force is acting, that is called moment of force. Moment act about a pivot in clockwise or anti-clockwise direction. Got this point?
Yes.
So it can be clockwise, it can be anti-clockwise or pivot. This three way it can apply the force. So force, the moment of force. How we can calculate the moment of force? The size of moment of force can be calculated using equation, that is moment of force equals to force that applying here. Okay, we denote it by F and multiplied by perpendicular distance from the pivot D. If we say this D, okay, how much distance is here? That will be used to calculate the moment of force. So this is perpendicular distance from the center point. Okay. So we'll write perpendicular distance from the pivot point. Okay. So if it is X distance, this is Y distance. So how we'll calculate the moment of force? So in short way, we can write like this. Moment equals to force is F into distance, we can represent as a D. Okay, multiplying force with the distance will give you the momental force. Okay. So what is the measurement unit of force?
Force times distance.
No, this is the multiplication of these two, the calculation of moment. Okay. So the unit of force is what? Newton, right?
Yes.
So distance d measure in what? Distance in meter, right?
Meter.
That means moment is measured in Newton meter. That will store like set like this. Then that means the unit of moment is what? Newton meter. Because the force is Newton,
Meter.
distance is meter. That's why it's a Newton meter. N will be capitalized. Why? Because this symbol has been taken from a scientist name Newton. Okay. If any unit name
Yes.
taken from scientist name, that will be in capital letter. Remember this one. Okay.
Okay.
So let's check this one. Here we say distance is say 10 meter. Okay. Y equals to 10 meter. Okay. And it's giving the force is giving is 10 Newton. So what will be the moment of force?
100.
100. Okay. That means moment equals to 10 Newton into 10 meter.
10.
That means should the 100 bolle hobe na 100 Newton meter. Okay.
Okay.
So this way you can calculate the moment of force. That means perpendicular distance will be taken from pivot point. So this will be what? Clockwise, because this is this side. Okay. This will be clockwise moment. The force will rotate the object in a clockwise direction about the pivot. So think about something you are putting here, and you are pushing, you are giving the force here, so it will go down, right? So it will be clockwise. If we put here right side, that means it will go anti-clockwise, right?
Yes.
So it is important to remember that the distance d is perpendicular distance from the pivot to the line of action of the force. The way we can see here in the diagram. Okay. Now let's check some question. A force of 15 Newton is applied to a door handle 12 centimeter from the hinge. Calculate the moment of force.
What? I don't understand.
So given that you are pushing, you are giving door handle, the force equals to 15 Newton. Okay. And hinge point means center point. Okay. Pivot point. Distance given 12 centimeter. So what will be the moment of force? Equals to what?
15 times 12.
No. Force is 15 Newton. Okay. Then multiply. And we know the distance must be calculated in a what?
In meters.
Okay. So how many centimeter is 1 meter?
10.
10. That means 12 divided by 10 meter, right?
Yes.
So if anything's given, distance given in any other measurement unit, then the meter, you must convert it to the meter. Remember this one. Okay.
Okay.
So now what will be the, we can cancel this one by 5, 3. This is 2. This is 6. That means 18 what?
18 moment.
8, not 18 moment. What is the unit of the moment? This Newton will come here. This meter will come here, Newton meter. You must write this unit, otherwise it will be wrong. Okay.
Okay. Wait, I think it's 100 meter.
Yes, you are right. 100 centimeter equals to 1 meter. So it will be divided by 100. So this is 20. Okay, this will be 10 and this will be 6. So this will be 18 by 10 equals to
Can't they be further divided by 2?
18 Newton meter. Okay. Very good.
Okay.
So this way you will need to convert it. Okay. So
Okay.
let's do another problem. A force of 40 Newton is applied to a spanner to turn a nut. You know spanner?
Spanner, a wrench.
Wrench, yes. So you are using a wrench to turn a nut. Okay. Nut, you know?
Okay.
This is called nut. Okay.
Okay.
Okay. So force is given what? 40 Newton. The perpendicular distance is 30 centimeter. That means 30 centimeter. So what you will need to do?
First, convert the 30 centimeter to meter.
Okay, that means 30 divided by how many centimeter? 1 meter? 100, right?
Yes. Yes.
That means 0 cancel, 0 cancel. This will be 0.30.
0.3.
Okay. So moment will be equals to F is 40 Newton into D is 0.30 meter. If we multiply this one, it will be what? We can write like this. Take this out. 100, 0, 0 cancel, 0, 0 cancel. That means 12 Newton meter. This is the answer. Okay.
Okay.
So this is a clockwise moment.
What about the anti-clockwise?
If the result comes with a minus sign, then it will be anti-clockwise. Like this. This is the pivot point, right? This is positive distance. This is negative distance. Okay. If we get any result with a minus, that means it will be anti-clockwise.
Oh. I think the turning effect chapter is done.
Turning effect done?
Yes. Wait, I have a question.
Yes.
Like, what if the object is like middle of the item and not equally distance?
Not equally distant.
Yes.
Okay, repeat the question again.
Like, can you draw a line?
Okay, line. Then
put the pivot point.
Pivot point.
And one is near the pivot point while the other is a bit far. How will you do that?
Okay. This is near, this is far. So what will happen?
Yes.
Say the distance is more. You can see the formula, right? Formula is what? Formula is force into distance. So if distance is more, that means the moment will be more, right?
Yes.
Because we are multiplying the distance. Like this, if I give 40 Newton and distance is 2, that means it will be moment will be 80 Newton meter, right?
Yes.
If we give 40 Newton and distance is 10, that means it will be 400 Newton meter, which is much bigger for the same force.
Yes.
Okay. So if you want to provide higher force with less effort, then you will need to go distance from the pivot point. Okay.
Okay.
Like this range, you know range?
Wait, can you wait 2 minutes?
Yes.
Hello.
Bolo.
Okay, continue.
Okay. So we'll go for one exam. Okay.
Okay.
Can you see this test?
Yes.
Okay. Now tell me, what is the unit of moment?
Newton.
Huh?
Newton.
Newton is the unit of force. What is the unit of moment?
Oh. Newton meter. Newton meter.
This one. Okay. What is the name is given to the shortest distance between a line of action of a force and the pivot?
Perpendicular.
Okay. What is the moment of 6 Newton force acting 1.5 meter from a pivot?
1.5 times 6. 9.
9 কোনটা? 9 তো দুইটা আছে।
9 Newton meter.
Newton meter. The moment of a force is 24 Newton centimeter. Okay. What size is the force if it acts 8 centimeter from the pivot?
Three.
Huh?
3. 3.
3. 3 what?
3 Newton.
Newton. What is the principle of moment?
Total clockwise force is equals to total anti-clockwise force.
What is the principle of moment?
For the second one.
Is the force or
Moment.
check? Think why you are saying such things? Tell me. Explain your answer.
The moment is a turning effect. So force is just the action.
Force is just a
the action, and moment is the main part as it is the turning effect.
so this will be this one, right?
Yes.
Okay. Two identical weight are attached to opposite end of a beam. Okay. Both are 1 meter from the pivot. What happens if the right hand weight is moved closer to the pivot?
If it is closer to the pivot,
I just explained a few seconds before.
the beam rotates clockwise.
The beam, what happens if the right hand weight is moved closer to the pivot?
The beam rotates clockwise.
Think about once again. Right hand weight is moving to the
Closer to the pivot.
right hand. Draw the diagram.
Okay. What is their force? Is their force is told?
Weight is same weight, but it was in both side 1 meter distance, but suddenly the right hand side going closer.
Due to the right one going closer, the right hand has less distance, thus giving him more force.
More force towards what?
Towards the right hand. Towards the right hand.
No. See here. This is beam, okay? This is pivot point. Here we have, let's say, X weight. Here we have X weight. That means it will be balanced, right? This is 1 meter. This is 1 meter. This is left. This is right. If I bring closer the right side one, okay, closer to the pivot point, what will happen?
All the force will decrease.
Which force will be decreased?
The right hand.
Then which will be increased?
The left.
That means this will go this way, right?
Yes.
Which is, what is this indicating?
This means that it's anti-clockwise.
Okay. So this is anti-clockwise. Understood?
Yes.
So if one side decreasing, the other side will be increasing. If right side increasing, it will be clockwise. If left side increasing, it will be anti-clockwise.
Anti-clockwise.
Now, which of the following is a correct definition of the center of gravity? You tell me. The center of gravity is the point through which the weight of an object appears to act for any orientation of the object. The center of gravity is the point at the middle of all objects. The center of gravity is the point through which the mass of an object appears to act for any orientation of the object. Which one?
The second one.
Why?
Because gravity doesn't affect the size no matter what. We pull the same.
That means center of gravity, the center of gravity of a body is that point where the total gravitational torque on the body is 0. Now you say.
Yes.
The middle one, okay? Which of the following is not required for an object to be stable?
The object should have a low center of gravity.
Low center of gravity. A vase of flour is found to be unstable. Which of the following will make it more stable? Remove the water from the vase, put some stone in the bottom of the vase, replace the flower with one with longer stems. Which
Put
one
some
will make?
water in the, put some stones in the bottom of the vase.
Yes. Which of the following statement about toppling over is false? The object will topple over if its center of gravity is inside its base. A object will topple over if its
The second one, an object is toppled over if its center of gravity is outside its base.
Okay, let's check your score. Okay, you have answered 7 correct question out of 10. So which one is wrong? Let's see this one. Correct definition of the center of gravity. The center of gravity is the point at the middle of all object, you said. It is incorrect. Correct is, that's not right. The center of gravity is the point through which the weight of an object appears to act for any orientational object. Remember this one. Okay?
Okay.
Center of gravity is the point through which the weight of an object appears to act for any orientation of the object. Okay? This is the definition of center of gravity. Now you made which of the following is not required for an object to be stable? The object should have a lower center of gravity, you said. Right answer is, the correct answer is the object should have a narrow base. An object with a narrow base is unstable. Okay. See, your answer was correct for if not was there. Okay.
Oh.
For this, you need to read the question properly. Which of the following is required for an object to be stable? Your answer is correct. Okay. Since the question is asking not required for an object to be stable. Okay. So next wrong answer is, which of the following statement about toppling over is false? Say what is said. It's a false. Topple over if its center of gravity is outside its base. It will topple over outside its base, but it asked that it should be false. Got this point? You have given the right answer if the question was like this. Which of the following statement about toppling over? If question is up to this, your answer is right. Since it said that is false, you need to check the question properly. False, that means which is not correct, that will be the correct answer. Okay. The object will not topple over if it is center of gravity is inside its base. That means it is the wrong answer. That's a correct answer. Got this point?
Yes.
So what is next topic?
Next topic. Center of mass we read. Stretching and compression. Stretching and compression.
Stretching and compression. Okay. What is stretching and compression? One second. So what do you mean by the stretching and compression?
Stretching is like pulling an object, and instead of it tearing or breaking off, it's like changing shape.
Okay. What is stretching? See, can you see this? This is stretching.
Yes.
Okay. This is stretching.
Okay.
Another one is what? Stretching and
Compression.
compression. Compression means what? This is stretching. Okay, you are stretching. That means it is
Yes.
increasing the size. But compressing means this is compressing. Okay.
This is decreasing
Decreasing
the size.
When you are stretching, this also a force. When you are decreasing, that also a force. So it's having 10 Newton. You are putting the 5 Newton force, so it's increasing. Okay. This is also part of force. Got this point?
Yes.
Let's see the another one. See here. Check this about the moment of force. See, this is unstable. Okay, this is in pivot.
Yes.
Pivot. So you said if I give this 5 here, if I give this 5 here, one inches long, so its weight is same since distance is long, so it's getting the more force, moment, right?
Yes.
So if I take this, or if I take this, we are giving it here. See, 5 kg force we are giving 5 Newton. If I give one, see, although it's a 1 Newton, but it's having more moment because of distance. Okay.
Yes.
So you understood this one. So next is stretching and stretching. You understood any other things you want to know about stretching?
No.
Okay, let's see this one. See, 200 gram. Okay, it's putting here. This is stretching. If I put downwards, this is actually we'll learn later that based on the weight, the Archimedes law, the similar amount of water is going. Okay, we'll learn later this one. So stretching is over. Stretching and so is there any math for this? Stretching and compression?
Yes.
Is there any math for this?
Stretching, the math is weight. There's one math that is in extension divided by load.
Yeah. So how we'll calculate the stretching? That means stretching and, okay, this is also kind of elasticity, right? Forces are responsible for changing the motion of object. If more than one force is present, the shape of object can also be changed. So stretching and compression is changing the shape, right? As you've seen before. Got this point? Yes. When a force acts on an object, the object may change shape by bending, stretching, or compressing, or combination of all three shape changes, right? If you have a ball, if you have a ball, okay, or a balloon, if you press from this side, what will happen? It will be like this, right?
Yes.
So it's changing the shape. Okay. Similarly, if you have a straight a stick, okay, and if you put pressure here, what will happen? It will change its shape, right?
Yes.
It's bending. The bending objects end past each other when an archer pulls an arrow back again a bow. So have you seen the bow? When you pull a arrow, what is happening? It's stressing, right?
Yes.
So this is stressing. Pull an object ends apart when a rubber band is stressed. Okay. Push an object ends together when the empty drink can is squeezed. Have you drink? Of course, you have drink can Coke, right?
Yes.
So after drinking, what you do? You give a pressure on the can, right?
Yes.
It's squeezed, change its shape. Okay.
Okay.
The change in shape is called what? Distortion. Okay.
Okay.
Two kind of distortion you will see. One is elastic distortion, is reserved when force is removed. Reversed when force is removed. Elastic. If you pull a plastic thing, okay, or elastic, what is happening? It's increasing in length, right? When you
Yes.
are releasing that one, it's going back to its original size, right? This is called
Yes.
elasticity. The another one is inelastic. Distortion is not fully reversed when the force is removed. That means there is permanent change in the shape. Okay. So distortion is how many kind? Two kind, elastic and inelastic. So rubber band, as we said, it's undergo elastic distortion when stressed a little. A metal drink can that you drink Coke from it undergoes inelastic distortion when it's squeezed, right? When you squeeze a Coke can, it's not coming back to its original shape again, right?
Yes.
So that's why it's an inelastic. One is elastic, another one is inelastic. Okay. So what is the formula?
The formula. Formula is extension divided by load.
Extension divided by force. Force or load?
Yes.
Extension load.
Yes.
Load means that's a constant. Okay. This is called actually happens when object increase in length, and compression happens when it decrease in length. Okay. The extension of an elastic object such as spring is described in a formula that's called Hooke's law. Hooke's law. Okay. That is what force equals to Kx. Here F is force, K is constant, spring constant. That means how strong spring is. If it is longer, strong, the constant will be more. If it is the thinner, the constant will be less. So this is called spring constant. Okay. And this is the extension, how much it increased. So extension or increase of length is measured in what? Meter. Okay.
Okay.
In length is measured in meter.
Meter.
Yes. Let's see some practical. Hooke's law. Let's see here, weightless. See,
Yes.
it's going down because weight is higher. So it's what is happening is torn. Okay.
Yes.
So when the 5 Newton is the G is what?
G is the constant.
Gravity.
Oh, gravity.
Yes. Let's see here. So this is spring. Okay. See, can you see the spring constant here?
Yes.
Okay. Spring constant is small. So if I put it here, the weight, it's increasing. Okay. Equilibrium position. This is equilibrium position. Length, neutral length. It's increase the length from this to this much. Okay. So let's make the scale from here. See, what is the extension? It's about 42, right?
42. Oh yes, 40. More than 40.
More than 40. So, or we can say it's a 40, okay? For our simplicity. So the value of X is what? 40. How much length it's happening, okay? This is the middle line, okay? So if we put the gravity, no gravity, gravity is 0, or we can put the gravity more. If we put lots of gravity, it will go down because gravity also working on this object, okay? Some we are giving earth gravity, okay? See here, if I put the constant more, okay, see the spring is what? Increasing. Spring
Increasing and increasing in
speed increasing, but speed, the thickness also increasing, right? The constant is more means thickness is increasing, and in the same time the distance is also reducing. It was previously 40, it is becoming 20. Can you see this?
Yes.
This one is becoming 20. as long as we move the spring constant less, it's increasing more. See, it's more than 80, right?
Yes.
Okay, spring constant is nothing but the how strong spring is. Okay, so for different kind of strongness, the different distance will go for the same weight. Weight is nothing but a force. Okay, here we are getting x value, we are getting the force. We can calculate the constant. How much we can calculate the constants of the spring. I mean the thickness of the spring. In the same way, if we have the constant, if we have the force, then we can calculate the distance it will move, stress it will move. Okay.
Okay.
Let's make slowing down. See. Got this point? So that
Yes.
means let's do a math. A force of 3 Newton is applied to a spring. Okay. Force equals to 3 Newton applied to a spring. Okay. The spring stretches reversely by distance or x, যেটাই বলো না কেন, x equals to 0.15 meter. The fact that the spring stress reversibly means that it will go back to its normal shape after the force has been removed. আমরা যখন ফোর্সটাকে রিমুভ করে দেই তখন নরমাল শেপে চলে যাচ্ছে না? হ্যাঁ। ওকে, ক্যালকুলেট দ্য স্প্রিং কনস্ট্যান্ট। স্প্রিং কনস্ট্যান্ট কত হবে তাহলে? তাহলে আমরা জানি কি F equals to kx, আমাদের বের করতে হবে k, দ্যাট মিন্স k equals to F by x, ঠিক আছে? F equals to 3 নিউটন আর x কত? 0.15 মিটার, রাইট? তাহলে এইটার এই কনস্ট্যান্টেরই কি হবে? এখানে দেখো নিউটন আছে, এখানে মিটার আছে, হ্যাঁ। তাহলে এটা হয়ে যাবে কি, এটাকে আমরা ডিভাইড করব, এটাতে ডিভাইড করলে কত যাবে? 20 হবে, 20 নিউটন হবে এখানে। তাহলে এখানে হবে 20 নিউটন লিখবো, যেহেতু এটা নিচে আছে, হ্যাঁ, এই জন্য আমরা স্ল্যাশ সাইন দেব, তারপর এম লিখবো। ওকে, 20 নিউটন পার মিটার। গট দিস পয়েন্ট? এটা মনে রাখবা কি, কনস্ট্যান্ট ইজ নিউটন পার মিটার, whereas moment is newton meter multiplication. Okay, got this point?
Yes.
Okay, all right. Now let's go for an exam. Okay.
Okay.
Let's do this. So how might the shape of an object changes if force act away from each other in straight line?
Shape of an object changes if force act away from each other in a straight line. It might extend.
How might the shape of an object change if force act away from each other in the straight line? It will be
might extend.
Okay, because it's going straight line. If it was not straight line, it might bend. Okay, if it was towards each other, it might compress.
Yes.
How might the shape of an object change if force act towards each other in a straight line? Now tell.
It might compress.
Okay. Which word describe an object that will return to its original shape when force are removed?
Elastic.
Elastic, exactly. Which word describe an object that will not return to its original shape when force are removed?
Inelastic.
Okay. What is another name for the limit of proportionality?
Elastic limit.
Elastic limit. What is the unit for the spring constant?
Newton per meter.
Newton per meter. Super. What is the name of energy stored by this stretch spring?
Elastic potential energy.
Exactly. Which equation gives the energy stored by a stretch spring?
E is equals to kx.
Exactly. A spring extends elastically by 10 centimeter when a force of 20 Newton is applied to it. What force would be needed to extend the spring by 5 centimeters? Calculate.
When a spring extends elastically by 10 centimeter, then a force of 20 is applied to it. So 10 Newton. Hello, 10 Newton. 10 Newton.
10 Newton.
Yes.
How?
If it takes 20 Newton to make it 10 centimeter, then it's the half, 10 Newton.
Okay, that's good. A spring extends elastically by 0.1 meter when a force of 2 Newton is applied. What is the value of its spring constant? Apply the value to the formula.
0.05.
No. Apply the formula. The value of x has been given. The value of f has been given. You need to find the k.
The K. Wait. .2.
No.
.20.
Yes. Why?
I don't know.
You don't know?
No.
Why you don't know? See what we have. We know what f equals to
F equals to force divided by Newton.
f equals to kx. Okay, k is the constant, right?
Kx.
We'll need to find
Yes.
the k. That means k equals to what? F by x, right?
Yes.
So f is what? 2 Newton.
F is 2 Newton.
And x is what? 0.1 meter. Okay, so we take this dot, put 1 0. So what will be 20 Newton
20.
Newton per meter. Okay, you need to understand this formula. If any two is given, the third one you can calculate. Okay,
Okay.
so it's a 20. Now let's check score.
9 out of 10.
Which one you made mistake? See. Why? Which equation gives the energy stored by stretch spring? Oh, energy stored by stress spring. Achha, we didn't explain this one. Okay. The value of kx is equal to the force acting on the spring. Okay, all right, no problems. It is not in your syllabus.
Oh, okay.
So what next?
Next, this is not important right now, so we will do this one in the future.
Which one? Tell me.
It says more about moments, like the one we just did, principle of moments.
It's just text, right?
Yes, it's just problems.
Problem is
like word problems.
Word problem.
Yes.
Okay. What are the question you have in this chapter? Tell me the question.
The question. The articulated truck shown on the left has two parts. The tractor with the cab, engine and driver, and the trailer which carries the load. এটাতে diagram দিতে হবে।
আচ্ছা ঠিক আছে, প্রবলেম গুলো আর কি প্রবলেম আছে?
এগুলো সব প্রবলেম একটা ডায়াগ্রাম দেখে করতে হবে।
এটা পারবা নিজে করতে পারবা?
এখন তো পারবো না, আমার কালকে হিস্টরি পরীক্ষা, তো এই জন্য বুকটা রিভিশন দিতে হবে।
হ্যাঁ রিভিশন দাও।
আচ্ছা
তাহলে কি পরীক্ষা?
কালকে হিস্টরি পরীক্ষা।
ঠিক আছে তাহলে হিস্টরি পড়ো। আজকে তো শেষ, কারো আছে কিছু?
আর কিছু নাই।
ওকে, অলরাইট, বাই।
বাই।